Okay, so let us look at this question. So they're saying glycolipids are complex lipids that have a variety of biological importance. Perhaps one of the best known functions of glycolipids is that they are constituents of biological membranes. Okay, then they're saying a certain glycolipid is made up of glycerol, two fatty acids whose shorthand notations are 24, 0, and 22, 5, 5, 8, 11, 15, and 18. Okay, and a disaccharide. So we have three things that are making up this glycolipid here. We have the glycerol, we have these two fatty acids, and the disaccharide. Okay, then they're saying the disaccharide is made up of galactose and glucose held by a beta 1 to 4 glycosidic bond. Okay, then they are further saying that the point of attachment of the disaccharide to the glycerol is by the glycosidic bond involving the anomeric carbon of the what? The galactose. And then the question now is draw this glycolipid. Okay, so it's very easy to draw this glycolipid, but first of all, we have to draw the glycerol on its own, the two fatty acids, and then the disaccharide. And then we'll be able to what? To join them to form this glycolipid. Okay, so let's draw the glycerol, the two fatty acids, and the disaccharide. So remember, this disaccharide is made up of the galactose and the glucose. So that is just simply what? Lactose. Okay, so let's draw them here. So I'll start with the glycerol. Okay, so we know that the glycerol is just a 3 carbon chain molecule that is in this form. So I have H there attached to a carbon, another carbon, another carbon, and then an H. Okay, and then these 3 carbons here are each attached to a carbon and a hydroxyl group. Okay, or an OL or H group. So OH here, even here we have OH. Okay, then here we have H, there we have H, even here we have H. So this is the glycerol that we are going to work with. Okay, so on this glycerol, on the first OH here, we are going to attach the first fatty acids. On the second one, we're going to attach the second fatty acid. On the third one, we're going to attach the disaccharide, which is made up of glucose, and glucose, which is simply what? Lactose. So let's draw the first fatty acid. We are told the shorthand was 24, and then full colony, and then we have 0. So this simply means that the fatty acid has 24 carbons, okay, and 0 double bonds, okay. So we know that a fatty acid will always have a what? The carboxylic group. So the carboxylic group is this group, guys. Okay, so if here there's a C, then this is attached to a what? To an OH like this. So this is a carboxylic group. So this carboxylic group was going to be attached to 24 what? Carbons. Okay, so let's write the first fatty acids here. It will just be, you first write the carboxylic group like that. Okay, and then you count 24 carbons. So the first carbon is just right here. So I'm going to say 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have drawn 24 carbons attached to this one. So this is the first fatty acid. And then the second fatty acid, we were told that it's what? Let's check here. So we are told this 22 full colony 5. So meaning it has 22 carbons, and then it has 5 double bonds. Okay, and then those 5 double bonds are placed at carbon number 5, 8, 11, 15, and 11. So 15 and 18, I mean. So that's what we are going to draw. So we are going first of all to put the carboxyl group here. Okay, and then you have your O. Then let's draw a chain of 22 carbons. So the first one is right here. So the next one will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, and then we are told that this has double bonds. Okay, and those double bonds are at 5. Okay, let me see here. They're at 5, 8, 7, 15, and 18. Okay, so let me write here 5, 8, 11, 15, and 18. So these are the places where we are going to find the double bonds. Okay, so we start counting. So this is 1, 2, 3, 4, and then 5. So the first double bond will be here. Carbon number 5, double bond, 6, 7, 8, another double bond. Okay, 9, 10, 11, another double bond. Okay, 12, 13, 14, 15, another double bond. 16, 17, 18, another double bond here. So 15, 16, 17, 18, another double bond. Okay, so those are the double bonds there that I've indicated in yellow. Okay, so this second fatty acid is going to attach here. This first one is going to attach there. And then on this third OH from the glycerol, we're going to attach the disaccharide, which is the what? The lactose. Okay, so how do we draw that lactose? Simply do it in this way. Okay, so we know that the lactose is made up of the galactose and the glucose, and then the galactose is like this. Okay, so you have your O here, then you come down like that. Even here, you do the same. Okay, and then like that. Okay, so here, this is our carbon 1, 2, 3, 4, 5. Then the sixth one comes out of the ring, which is like that. 2OH. Okay, and then here you have an OH down on the galactose. Here you have an OH up. So you have to know how to do these things, guys. You have to memorize them. So here you have OH. Okay, and then here now, this here will combine with an oxygen to form the beta 1 to 4 glycosidic bond. So here now, on the other side, you're going to have your what? So your glucose. Okay, so this will go like that, to go like that, that. So here you're going to have OH. Okay, even down there you're going to have OH. Of course, you have OH here. And then there you're going to have your what? OH like this. So this, what I've drawn here, is what we call as lactose. Okay, so here there's that beta 1 to 4 glycosidic bond. So why are we saying 1 to 4 glycosidic bonds? Because of this. So this is carbon 1, 2, 3. We have carbon 4 here, 5, and then we have 6. Okay, and then from here we have 1, 2, 3. We have 4, 5, and then we have 6 that is outside the ring there. So you see that the bond is between carbon 1 of the galactose to the carbon 4 of the glucose. Okay, the one that is beta 1 to 4 glycosidic bond. So it means this disaccharide here is the one that will come and combine with this OH. Okay, the one that will come and combine with this OH. So how does the combination happen? Okay, so you've seen on this carboxylic acid of the first fatty acid, we have OH. Even there we have OH. Okay, so this OH here and this OH, they're going to react. So what will happen is that from the acid, you're going to get the OH, and then from the glycerol, okay, so this is glycerol here. Okay, so from the glycerol, we're just going to get H. So it means water is going to be removed here because you have OH combining with the H. So it's going to form water. And then this oxygen here will be directly bonded to the what? To this carbon that is there. Okay, and then here the same thing will happen. You only get the hydrogen from here. Then this OH here is going to combine that hydrogen to come up with water. Okay, and then this last OH here, when it reacts with the anomeric carbon, so the anomeric carbon is this carbon 1 on this galactose here. When this OH reacts with this, so remember in organic chemistry we said carbon forms how many bonds? 4. So it means here there's a hydrogen that we are not showing like that. Okay, so we have oxygen, carbon, oxygen, hydrogen. Okay, so there's an hydrogen that we are not showing here. So it means this OH here will come and react with this hydrogen here. Okay, and then a water molecule will go. So now this OH and this hydrogen will form a water molecule. So it means now this carbon here will come and react with this carbon here to form a bond. And when they react, we would have formed our what? Our glycolipid. Okay, so now let's draw this glycolipid. Okay, so follow through what I'm going to do. So I'm just going to connect this to the first one, this to the second one, and then this disaccharide to the last one. Okay, so let's draw it. Okay, so I'm going to say my glycerol will be here. H, we have H. Okay, so remember here we are the OH. So that H has gone with the OH from the acid, so we are remaining with what? O. And then this O here, okay, is bonding to a carbon that is here, which is bonded, which is double bonded to an oxygen, okay? And then this here has to form a chain of 24, because that first fatty acid has 24, right? So we're going to say this will be the first carbon here. So the second carbon will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Have I drawn it right? Okay, let's count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, so I draw an extra carbon there. So yay, everything has gone, but I know it's fine. So we're saying 1 is here, and then we're going 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so we have connected the what? The first carbon there. So this one is double bonded to the oxygen there. Then here we're going to have an oxygen, as usual, to be double bonded. And then remember now, what we have here is a unsaturated hydrocarbon, because there are these double bonds here. So it's a 22 chain, it's a 22 carbon chain. So this is 1, we're going to say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, 22, and then we include those double bonds at specific locations. Okay, so we are at 5, 8, 11, 15, and 18. So this is the 1, 2, 3, 4. So at 5, we are going to put a double bond. 6, 7, 8, put a double bond. 9, 10, 11, we put a double bond. 12, 13, 14, 15, we put a double bond. 16, 17, 18, we put a double bond. Okay, so those are the 5 double bonds that we can put. And then this last one here, okay, is going to attach to the glycosidic bond. So remember what I explained here, okay? This OH, okay, this OH here is going to react with the H at this anomeric carbon. So this OH and this H will form water, and this water will go away, okay? So what we have is this carbon here coming to attach here. Okay, so we have a bond like that going to the what? To the carbon. So that's what I'm going to show. So in short, I'm just going to draw this, and then I'll draw a line that comes to the to the disaccharide there. Okay, so this is my glycolipid. We're forming it. So we are going to say, let's first draw our disaccharide. So I'm going to say this is our disaccharide. Okay, let me just draw it properly there. Okay, so we have O there. Then we have that. Okay, I should draw these things nicely. This is not a good drawing. Okay, yeah, this is good. And then we also have a glucose molecule there. So we have an oxygen there and then like that. Okay, so we have OH there. Even there we have OH. Even here we have OH. Okay, then there we have CH2OH. Yeah, and we know that this guy here is bonded to the oxygen there, which is bonded to this guy. Okay, then on the galactose, we have OH again, and then we have OH there. Then we have OH here. Okay, and then we have C2OH. Okay, so notice that this here is the anomeric carbon of galactose because this is galactose here. The first one is galactose. Okay, the first one is galactose. The second one is what? Glucose. So what will happen is that this one here, the carbon will come and it will react with this guy, the anomeric carbon here. Okay, so that will be the bond there. So I'm just out of space here. Otherwise, you can make this disaccharide move a bit to the left. Okay, so that you just draw a straight line like that. That will come and connect here. Okay, it will come like that, and then it connects there. So it shows that this carbon here is connected to this. So we have this glycerol here. Okay, being connected to 2 fatty acids and a disaccharide. So it becomes a what? A glycolipid. Okay, so in the question they stated that we should number these carbons. Okay, so for the fatty acid, this is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, we have 14 here, 15, 16, 17, 18, 19, 20. Okay, 20, 21, 22, 23, and then 24. Okay, so we do the same for this one here. We're going to say 1, 2, 3. This is 4, 5, 6, 7, 8, 9, 10, 11. We have 12, 13, 14, 15, 16, 17. And then we have 18 here, 19, 20, 21, and then 22. So make sure you saw the number. Okay, make sure you show the number. And then on the other part, even on this disaccharide here, we are going to number it 1, 2, we have 3 there, 4, 5, and then 6. Okay, you pin here to be 1, 2, 3, 4, 5, and then we have 6. Okay, so what we've drawn here is a what? A glycolipid. Okay, so that's how you draw a glycolipid here. We've answered question 1. So that's all for this video.